Welcome to a product presentation of KNUR DCD, high-performance cooling system from Emerson Network Power for high-performance computing. Today we are at the Helmholtz Center for Heavy Iron Research in Darmstadt. Darmstadt is located approximately 30 kilometers south of Rhein-Main Frankfurt Airport. And with me is Volker Lindenstruth. Volker is head of IT here in GSI in Darmstadt and heads all the data centers. Volker, you operate the KNUR DCD for a while. Just could you summarize a little bit your experience, especially since we have the rear-door heat exchanger on the backside of the server rack and feed cold air back in this nice data center?
Well, first of all, it is an architecture which is very simple and simply works. All the centers we have, and there is quite a few, were basically turned on and are running since without any issues. The warm air leaving the computer equipment, and that includes ordinary computers, not only high-performance computers, is basically cooled back by these heat exchangers and then fed back into the room. Since now there is no need for any cold aisle containment, hot aisle containment, etc. We can mount the racks any way we want, and as you see here, we have them even in the two-story kind of housing. The heat exchanger is designed in a rather smart way, such that it produces almost no back pressure. In numbers, we're talking something like 20 Pascal, which also means that the rack doesn't have to be perfectly sealed, particularly areas where you have to feed cables in and out are never perfectly closed, doesn't matter. Consequently, the entire system is very simple and easy to maintain. No regulation of water flow, airflow in any form. We just have to pump the water through the heat exchanger.
Could you just tell us a little bit about the conditions, chilled water feed, chilled water return, outside temperatures? What's the targeting temperature here in this data center?
Well, we don't have a fixed set target temperature. At the moment we are running at probably 21, 22 degrees. The system is designed such that you have delta T between cold water in and out of 3 degrees. Effectively it's a little less. And what is important is the air temperature leaving the heat exchanger corresponds to the cold water return temperature. So that is how we regulate the room temperature.
So it sounds pretty easy. Another question, some users or customers are a little bit doubt about the back pressure on this heat exchanger mounted in the rear door. What's your experience in using your computer equipment?
It doesn't matter at all. And there the argument is valid to talk about high-performance computers, because there the power density is largest. We have reached more than 700, 800 watts per hydro unit. It really doesn't matter. We have measured it in various ways. One example is we measure the exact power which is drawn by all computers in a rack. Opening or closing the doors doesn't have any impact. Would opening the door mean something? For instance, reducing a large amount of pressure, then the fans would draw less power, and we would see that. We have also measured it by really measuring the individual fan power. Again, no impact. This is, I would say, a red herring.
Okay. Now I remember back 2-3 years ago we did some tests in our test lab in Lommatzsch, so we saw an increase of the fan speed related to the ambient or to the temperature in the data center. So when we reached a very, very high temperature, we're talking about 35 degrees C, then we had an increase of 7% of the whole total power draw.
Yeah, but that has to be taken in respect. Those servers having a measurable temperature increase were one height unit pizza boxes with counter rotating fans. This is the most inefficient way to run fans possible. Okay. We use 2 height unit machines, and there you will be hard pressed to measure anything. The total power drawn by those fans in the servers relative to the server is at 6% total power when it's running. Okay. So there cannot be an increase of that much.
Well, when it comes in summer, you said the room temperature here is related to the weather conditions, ambient temperature outside. So what's the maximum temperature you face here in this room?
By design, our cold water return, and therefore the room temperature is about 7 degrees above the wet bulb temperature.
Okay.
The wet bulb temperature can reach 21 degrees in Germany, which means room temperatures of 28 degrees. All IT equipment we have is rated to run at a minimum of 35 degrees 24/7. So we are still very far away. And at normal days, like 90% of the year, the room temperature is around 22, 24 degrees.
So temperature-wise, this system, you don't see an issue. Another question is how you modulate or regulate the chilled water flow rate, because we don't have valve or flow regulating system at this particular product, at this particular door. So what is the device to control the flow rate?
Well, it's not needed. First of all, there is a Tischelmann system here, which means the same amount of water flow goes to every individual rack, and we're talking about 5 cubic meters per hour. The back cooling system simply measures the cold water return temperature and regulates the cooling system to keep this constant. That's all.
That's all. So another detail we designed in this Knurr DCD is the swivel joint to avoid flexible hoses or piping by opening the rear door. What is your experience with this particular detail?
We have a system at CERN where we have some 50 plus racks installed like that. Very unpleasant, and you produce torque on the pipes.
Yeah.
There's something where I would feel quite uneasy about, where in fact we never had a leak there either, and this system is run at 6 and 8 bar pressures. But it produces also a torque on the door, which always wants to close itself, and it's really unpleasant to work in with this environment.
I see. Yeah, another question. We see here a lot of sensors, seems temperature sensors on the rear door. Could you tell us a little bit about the purpose of these sensors?
Very simple. This is safety number 3. One of the things you have, I mean, we're here in a room which can dissipate up to 2 megawatts of power. Should the cooling system completely fail, the temperature will rise in here relatively fast. We're talking something like 5 to 10 degrees per hour. So we still have time to do something, but you don't have an entire night. The servers will shut down if there is an overheating, and the cooling system will fire an alarm if there is a risk of overheating. But should everything else fail, we have intelligent PDUs which measure the temperature independently and then cut the power if we reach a certain temperature, which I believe at this point is set to be at 40 degrees room temperature, which is relatively warm.
So the operation here in this room is on a very safe side, and you put all the levels of redundancy in that nothing can fail in this particular case.
Well, and if something were to fail, we don't destroy the equipment.
Okay, yeah, which is very important. Well, thank you very much to talk about the Knurr DCD, the server rack or cooling system from Emerson Network Power, and wish you great success here at this location with all the data centers.
Thank you
Very much.